Quick Trig, episode 2. Alright, we're looking at Pythagorean identities. So I'm going to draw myself a right triangle. Got a right angle right there, angle theta. For this one, I want the side adjacent to this angle, but not the hypotenuse, to be length 1. I'm going to call this side y and this side s. Okay. According to the definition of the tangent of theta, it should be the opposite side over the adjacent side, so that should be y divided by 1. But y divided by 1 is just y, so that tells me that y is equal to the tangent of theta. So this length right here is tangent of theta. Likewise, if I look at the secant of theta, the definition of the secant of theta would be the hypotenuse divided by the adjacent side, so that would be s divided by 1. But s divided by 1 is just s, so this tells me that s is equal to secant theta. So the length of the hypotenuse, if the adjacent side has length 1, the angle of theta, the length of the hypotenuse, is the secant of the angle theta. Okay. Now, remember what our buddy Pythagoras tells us. Pythagoras says that for any right triangle, if you have side lengths a and b and hypotenuse length c, that a squared plus b squared equals c squared. So what does Pythagoras tell us about this triangle? Well, Pythagoras tells us that 1 squared plus tangent squared theta should equal secant squared theta. Now normally we write the 1 squared as a 1, so I'm going to rewrite this as 1 plus the tangent squared theta equals the secant squared theta. So there is my second Pythagorean identity based on the Pythagorean theorem and this triangle. Stay tuned for the third in episode 3.